Normal Gravity, Chapter C, a little calculus review. C1, common derivatives. I'm going to give you the function here. Y is f of x, and then we'll give you underneath it the derivative, which will be dy dx, which you can write, if you'd like, as d f of x dx. If we have x to the n, the derivative is found by bringing the n down, and then having x to the n minus 1. For the cosine of x, the derivative is minus the sine of x. And the derivative of the sine of x is the cosine of x. The derivative of e to the x is e to the x. And the derivative of the natural logarithm of x is 1 over x. Now, if you want to see these derived, I do have a course called Basic Calculus, where I derive the equations. This course that you're taking here, Normal Gravity, assumes that you've had 3 semesters of calculus and two semesters of calculus-based intro physics. But it wouldn't hurt to review that basic calculus and these derivations to get sharpened up if it's been a while since you've had calculus. Notice that this n does not have to be a whole number like 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. It can be pi. It can be minus a half. And if you're interested in that, there's another lecture that I have put together in reviewing some things for this course in Chapter B. So we looked at that in Chapter B. This is the general result. If that's pi, then this is a pi here, and that's pi minus 1 as an exponent, and it works. Let's look at here A, the chain rule. Now the chain rule can be written as a derivative of y with respect to x, where y is a function of u. So suppose y is a function of u, and then u is a function of x. What you would do first here in the chain rule is you would take dy du in this specific case, and then you would have du dx. That's the chain rule. So let's give an example. Suppose I want to take the derivative of the square root of 1 minus x squared. Now, to illustrate how this is done, I'm going to do it 2 ways. The first way is the quick way. If you've done this a while, you would simply, for this derivative, you would simply look at this as 1 minus x squared to the 1/2 power. All right, this is 1 minus x squared to the 1/2 power. You'd pull down the 1/2. You then subtract 1 to get minus 1/2. This is using this rule here, where n is 1/2. And then you would take the derivative of what's inside, which is the derivative of 1 is 0, and then the derivative of minus x squared is minus 2x. And then you would be finished. You would then here, you write it, you would probably just write this as the 1/2 and the 2 canceling. So the 2's would cancel, you'd have minus x divided by the square root of 1 minus x squared. So that would be the result. But now I want to do it in detail, great detail. I would say I would let u equal 1 minus x squared, this what's inside here, and then I would write down for the y is the square root of u, where if I go ahead and put the u in, I get this. So I'm doing the same problem. See, we're doing the same problem. But this y, we're letting it be a function of u, the square root of u, and then the u is the 1 minus x squared. So if you do it in this fashion, you could then apply the chain rule. And for the chain rule, you would have dy du is equal to du to the 1/2 du. You'd bring the 1/2 down. You'd then subtract 1 and get then minus 1/2, and you'd be finished. So this would be 1 over 2, the square root of u. Then you would look at du dx, the second part, and that would be d dx of the 1 minus x squared. The derivative of 1 is 0, and this would be minus 2x. Then you would put them together. So dy dx would be dy du dx, chain rule. And you then copy these down like this. And this would be minus 2x. 2's would cancel. You'd have minus x over the square root of u. And then when you put in for the u, here's the u. Remember, this is the u. So when you put in for the u, you'd have minus x over the square root of 1 minus x squared. And that's what we got the fast way. Part B, the product rule. The product rule is taking the derivative of a product of functions. Say there's an f of x, there's an f of x, and there's a g of x, and you multiply them together. The rule is you take the derivative of the first times the second, and then you add the first times the derivative of the second. And that's the product rule. To give you an example, suppose we were doing the derivative of x e to the x. All right, so let me just block this off as that's the rule. So the derivative of the first would be the derivative of x with respect to x is a 1. And then you would multiply times the second one, the g. So this is the f, and this is the g. Then you would take the first one, x, and multiply it by the derivative of the second. Well, the derivative of e to the x is e to the x again. So this would be the answer. And you could factor out the e to the x, and you'd have 1 plus x. That's the answer, using the product rule. C, the quotient rule. Now, I don't like the quotient rule. I don't want to even remember it. And the reason why is because I love the product rule. I'm in love with the product rule. So when you give me, say, a quotient like d dx, say f divided by g, I'm going to write this as d dx f times g to the minus 1. I just made it a product. So g to the minus 1 is 1 over g. Now I know how to do the product rule, so watch watch this. We go ahead and for the product rule, we would have, let's go ahead and start down here. The derivative of the well, actually, this is the derivative of f over g. So we just write that. I've transformed it into a product. And now I take the derivative of the first, and that's df dx, and multiply it by the second, which is g to the minus 1, which I'll write down as 1 over g. And then I have the first times the derivative of the second. The derivative of the g to the minus 1, I've used the chain rule. Bring the minus 1 down, and then subtract 1 here, so I get minus g to the minus 2. And then I would use the chain rule. I would take the dg dx like this. And I would get then here df dx, that's simply f prime. I'll just put f prime there over g. And then this second one is a minus sign. This is f over g squared, and this dg dx is g prime in shorthand notation. All right, so f prime is this, and this one here is g prime. That's the answer. Now I can here at this point find a common denominator. I could do that. And if I find a common denominator, g squared, I would have f prime times g minus f g prime. And this is the quotient rule. See, I derived it using the product rule. I don't want to memorize this, but if you like it, go ahead and memorize this subjective choice. You know, you would take the derivative of the first times the second, minus the first times the derivative of the second, but then you put over g squared, the second one squared. But here I just am happy to use the product rule. Why memorize two formulas if you can use one in both cases? And in fact, this is the derivation. This is what it is, the quotient rule. All right, so now let's look at a situation. I would like to do a problem. I would like to do an example problem here that when I was away from calculus for a while, I kind of forgot what they did. So I want to review this one for you. So we're finished talking about these basic rules, and now we're going to do y equals the inverse tangent of x. And sometimes folks write that as the arctangent, A-R-C, T-A-N. And the way to do this, well, if you had this equation, you could write x is the tangent of y. Now, when I work this out, we're going to be using some of the principles we discussed above here as this example. So you can think of this also as an example of our principles. So what I'm going to do is take the derivative of this with respect to x. Well, the left side is dx dx, and the right side is dx, the tangent of y. Now here, dx dx is 1, and I'm going to now apply the chain rule. Since I have a y and I want a d dx, I'm going to do here d dy of the tangent of y, and then dy dx, using some of the things that we've already talked about earlier in this class. So then when we get up to here, we'll have 1 equals d dy. And now what's the tangent of y? Well, that's equal to the sine of y over the cosine of y. And I'll have dy dx. Now we see that we have the quotient rule. We can now use this rule to do this, where the f is the sine of y and the g is the cosine of y, all right? But I'm going to use the product rule since I like the product rule. So I have 1 equals d dy, and this will be the sine of y times the cosine of y to the minus 1 power. And this will be then, we just put this dy dx down again. All right, so now using the product rule, we would take here the derivative of the first, which would be cosine of y, times the second, which should be 1 over the cosine of y, plus the first times the derivative of the second. Well, what would bring down, I would bring down here the minus 1 cosine of y, then to the minus 2. But then I'm using the chain rule now, which I need to have the derivative of this cosine of y. See, so I brought the 1 down and had the minus 2, but then what's the derivative of the cosine of y? Well, that's equal to negative the sine of y. And I still have this dy dx hanging around. Now here, let's put the brackets here so that we have all of this inside multiplying dy dx. Now if we look at this, all this inside here, we like to work this out. We're going to have, well, there'll be a y, a 1. There'll be a 1 here, and then there'll be all this stuff in here. Well, this is equal to 1. And this here, if you look at the 2 minus signs canceling, and then the sine of y times the sine of y, we're going to have the sine squared of y. But then the minus 2 means we'll be dividing by the cosine squared of y, like this, dy dx. This thing in here is the tangent squared of y. All right, let's see if we can pull all this together. And dy dx, this is the amazing part. Dy dx is the derivative of the tough thing. This is the derivative of the arc tangent, which is what we were trying to solve for. So we have the answer. We have the derivative of the arc tangent of x is equal to 1 divided by 1 plus the tangent squared of y. So this 1 is up here, and then all this, 1 plus the tangent squared of y is down there, and then we have the derivative. But now watch this. The tangent of y is x. So this is nothing but x squared. And we have the result. The derivative is 1 over 1 plus x squared. Isn't that wild? Beautiful example. And it reviews some of the concepts that we've talked about in calculus here.